global. We at J2 Global, we do cloud services for businesses. Before I start my presentation, I want to just see how many people here used OpenSIPS or done. So by showing hands, how many people here used OpenSIPS?
Am I counting?
Play with it. Except Bogdan. So, how many people are new to OpenSIPS, never used it before? So, okay. And people that are using it, how many are still on OpenSIPS 1.4? 1.6? 1.8? Okay. Well, I had some good news for people. Oh, you're 1.5? Well, I have some good news for you. So right now, today, they released 110. And after that will be 120, 130, 140. So when it's 150, you don't need to upgrade because if you only wait another couple of years, then So again, J2, we have eFax, eVoice, FuseMail, Campaigner, Keep It Safe, OneBox, and you can go to j2.com. I have to have that slide here because my boss pays for the trip and this stuff, so I have to tell him that I present J2. And so please go to j2.com, try to see if you can sign up for anything. And so today I'm talking about, first we'll talk about SIP a little bit, because after all, OpenSIPS is all about SIP. Just do a little bit of introduction about SIP, telephony, voice over IP. Then I'm going to talk about proxy servers, like how you can use proxy servers in your network, and then talk a little bit more about OpenSIPS, and then questions. By the way, if you look at the schedule of the summit today, first you can tell who did the schedule. Because Bogdan gave himself 1 hour and everybody else half an hour.
And he went over that hour too.
What's that? Yeah, he went over too. It's like, I'm taking over. But it's an open source community, so we made some changes, so I'm going to have 45 minutes. Yeah. And then, so sip. Well, if you ever had a beer, that's what you do, you sip, you drink. That's one use of sip. And then, but when it comes to telephony, SIP is a protocol. So mainly a voice over IP protocol. And there are other voice over IP protocols. Mainly there is H323, which was implemented or standardized by ITUT. And then IETF said, we own internet. They did SIP. And then most companies started with H323, but eventually SIP won. So, and mainly because it was simpler, it was, text-based, more flexible, it had more network ideas in it. And then and media is also RTP. So now we have SIP. So what's voice over IP? The best way to talk about voice over IP, how we came into this voice over IP thing, is to talk about the history of it. So, and the history started a really long time ago. It sounds like it's a new thing, but not really. It actually started in 1892 when they made the first phone call. As you can see, a bunch of guys got together. There's no women there. There's no women here. So always when it was telephony, it was guys making phone calls. And so eventually, at the end, the true users are women because they're on the phone all the time. But we have to do the design work. So in telephony, you have cables, and you still need cables. Like a phone needs a cable. I wish they never invented some sort of telephony without cables. Not yet, at least. Like even in VoIP, you still need a network cable. And then so when the whole this, PSTN and all PBXs and stuff was like lots of cables. And then cabling, people did all these cabling work and that kind of thing. There was like connecting terminals, patches, and patch panels, so I want to show you OpenSIPS version 1. And that's Bogdan, maybe a different Bogdan. But this is basically OpenSIPS. What it is that, all these channels, cables come in, and then they go out from the other side, or vice versa. And that's the whole idea of the proxy servers or OpenSIPS. And it's not only, this concept of middleman is used in every industry, in everything. So like for networking, you always have these patch panels, like, these networks come in and then they go out. They never, like if you have a service provider, you buy something, they don't just give you a cable and then you connect it to your PBX or your end device. You always have this middleman that you use for, it sits in the middle, it gives you control, it provides security and that kind of thing. And it's used in everything again. So in IP, in internet, we have firewalls, routers, NATs. In ISDN, we have gateways. Even for power distribution, you have distribution panels. Like they don't give you the power cable hook it up to your house. First it goes to these distribution panels. Again, for water or same thing at airports, you have transit. So people come in, go through security, they go to this transit area, and then they fly out or vice versa. And that's the idea of OpenSIPS. It's this middleman that does the exact same thing as an airport transit that, sits in the middle. So when it comes to VoIP, then you need OpenSIPS to have that functionality, which is because in VoIP you don't have cables, it's all IP addresses. You have one cable, but everything is voice over IP. You have IP addresses, you have these channels or ports, trunks, but really it's all data. And then so OpenSIPS would sit in the middle or at the edge of your network, and then all the calls or messages come into OpenSIPS, and then in OpenSIPS you can control, manipulate, change, trace, decide how to be routed, and then send it out. That was my part of presentation about SIP, VoIP, and that idea. Now chapter 2, proxy servers. So first of all, proxy servers has lots of names. Some call it SBC, some call it back-to-back user agent, some call it SIP router. If you go to RFC 3261, which is the SIP protocol, you can't find this word. If you search for SBC or session border controller, it doesn't exist there. Or a SIP router doesn't exist there. It's a proxy server from SIP point of view. Everything is a proxy server. And but there are different, and SBCs or back-to-back user agent it's a form of the proxy server. So a back-to-back user agent is still a proxy server, but it's like one leg doesn't see, one side doesn't see the other side. The guy in the middle is acting as a back-to-back user agent. SBC is more a commercial term for a proxy server. So companies that they say we sell it SBC is just a commercial term for a proxy server kind of thing. And SIP router as well. But basically, they're all proxy server. So why would we need a proxy server? First is performance. So this middleman actually does not slow things down. It actually makes things faster. Why? Because so now all the messages are coming to this, proxy server. So the proxy server can, if a message is not meant to be for you, if it's a security breach message, if that call is not invalid, it can drop that message. So it would not, go all the way to your, let's say PBX, if you're using FreeSwitch, Asterisk, or any other PBX. So OpenSIPS can take care of a lot of things before the call actually reaches your media gateways or your PBXs. And that will improve the performance. For instance, it can act as a registrar server, so your SIP clients would not need to register to your PBXs. So that all of a sudden reduces a lot of traffic from your backend devices, because this proxy server can take care of a lot of functionality for you on the edge and gives you lots of control, and then that gives you a better performance. Second one, security and authentication. Again, like we were talking about airport transit, the people go through security and they're in this transit area. That exact concept would exist in a proxy server. So when a message comes in, an invite comes in, you can really validate if that message is for you. If it's you can authenticate it. You can also look into different ways of really not like authentication. You can do authentication with 401, say ask for username and password. But even before that, you can look inside your message and then see, is this really for me? Is this a valid message? And tell you the truth, so I'll talk about security later in some other slides. But this is the best way to protect your networks and to detect malicious messages that are coming to you. The other advantage, flexibility. So Bogdan was talking about it, that in OpenSIPS there are over 120 modules, and it gives you routing features and load distribution, load balancing, and all that kind of thing. But really the idea is it gives you flexibility. So when a message comes in, again, a call comes in, you can decide what you want to do. You have control. You can route it or give it priority or reroute it and that kind of thing, and customize it the way you want to do. NAT, voice over IP, the biggest challenge is NAT. You have a public IP address, you have local IP addresses, you might have different media, so your clients are behind NAT. Nobody uses public IP addresses. You don't want to use public IP addresses. So NAT handling is a big challenge. And then proxy servers or OpenSIPS, they give you that flexibility, so you can really do proper NAT handling. Every PBX like Asterisk or FreeSwitch, they have some NAT handling features. You can say this is my public IP, this is my use this and that kind of thing. But you can still run into certain scenarios that a FreeSwitch or Asterisk cannot handle, or your PBX. But because we have flexibility in OpenSIPS, you really have control in every aspect and every message, then we can do much better NAT handling. Redundancy, again, you can have redundancy in multiple levels or at high availability. What is a call comes in, let's say you want to make an ongoing call, you go to your carrier, doesn't respond, it's down, it does failure detection, and you can go to a failure route. You can reroute it and reroute it. So basically, or a call comes in, your Asterisk server number 1 or FreeSwitch is down, you can route it to a secondary server. So it provides redundancy and high availability. Distribution again. So you can have, so a call comes into OpenSIPS, and then it says, oh, this call is a European call. I can terminate it on my gateway in Europe. So if you have a distributed network or you have distributed across North America, again, you can use OpenSIPS. You need to use something like a Proxy Server OpenSIPS to handle distribution. And, of course, routing. So when we're talking about call handling, we're talking about routing. Because a call comes in, you want your international calls go this way, your local calls go that way. Different calls, different codes. If it's a fax number, you want it to end, you send it to your fax server. If it's a conference number, you want it to go to your conference server. So the idea of telephony is all about routing, and that's the major feature of OpenSIPS. And you can have rules, priorities, and that kind of thing. What else we can do with OpenSIPS? Load balancing, and that's another thing. So if you have one media gateway and one proxy, one media gateway or one PBX, you don't need to do load balancing. But the chances are that you're not going to be, one is not going to be good enough for you, because that's a single point of failure. That's you might have different servers for different functionalities. So load balancing, we'll talk a little bit about load balancing at the end. And that's a really neat feature of OpenSIPS, and not every proxy server has that load balancer module that OpenSIPS does. The other one is SIG signaling, codec, and digit manipulations. So, different gateways, some put +1 in front of the numbers, some don't put +1. So you can do, every message goes through OpenSIPS, and it gives you the flexibility to manipulate those messages. You change your codecs, change your to, from, user agent header, or anything you wanted that SIP signaling. You can do scripting. So there are over 120 modules in OpenSIPS. But if you need some feature or you need some behavior that those modules don't provide, you can script it. You can write a piece, sort of your own software, either in Perl or within the OpenSIPS routing script, and implement your own feature, your own way of handling you want to do it. So that's the other advantage of doing using in OpenSIPS. Resource allocation, again, same idea as load balancing. So you say, this server, this IP address is my conference server, this is for my fax, this is for my phone calls, and so you can allocate resources to your different gateways, and then when a call comes in, he knows how many resources or how many channels are available for fax and how many is free in each server, and then he routes the call based on that, or rate limiting, which is if you talk to carriers, that's very important. They usually have 20, 30 call per second limit. So if you send them more than 20 call per second, the call won't go through. And usually you don't have control on that. Let's say you have 2,000 users. You don't know how, there might be at times that more than 20 people will pick up the phone and make calls. You can't control when they make calls. And Astros or FreeSwitch or your PBXs, they don't give you control that what number, when a call comes in, they just send it out. You can't control that, I only want to make 20 calls per second. But in OpenSIPS, you can control that. So if it's more than 20 calls per second, try my second carrier. Don't send it to the first carrier, because that can only handle 20 calls per second. And media proxy. So OpenSIPS natively doesn't have media, it only does SIP signal. Or a proxy server does SIP signaling, but there are modules of software or hardware that you can also do media proxy. When would you want to do media proxy? NAT or some sort of NAT, you want all the media comes to this box and then from there goes to your local servers. Or you can do direct speech paths. Like if you have a firewall or router, you can configure direct route. So when it comes to that IP address, it will go to that media gateway. And so your RTP handling would be done there too. So now let's talk about, we're going to talk about open source for a bit, because when you have choices between commercial, proxy servers and open source, there are whole lots of SBCs, Acme, Dialogic, maybe at least like 20 of them, and there are some open source. So open source is free, so you don't have to pay for it. But it's also better. I believe it's better, and I tell you why. Because it gives you more flexibility, and because it's open source, you can go and change if you really want to change it to do something that you want to do in the species. Like you buy an Acme SBC, it has 800 features that you probably need 12 of those. Like your requirements needs 12 features, right? So you really don't need 700 of those features. You only need 12 features, but it doesn't have 2 of the features that you actually need. They implement lots of features, but every network, every requirement is different. So it's something you need to do with Acme SBC that it doesn't do for you. But when it's open source, you can actually go and do whatever you want to do yourself. And also it gives you independence. So there are lots of SBCs companies that went under. Like I know a company, they use VocalTech. Have you ever heard of it?
VocalTech, Netanya?
What's that?
Is VocalTech the one from Netanya? Sorry.
No, it's VocalTech. Have you heard of VocalTech?
Yeah, it's the older one.
They got bought, acquired a couple of times.
Yeah.
So they use VocalTech to build their whole infrastructure using their APIs. A call comes in, they design this whole host of PBX solutions, they sold it. VocalTech went under. It didn't go under like the SBC, just they stopped developing it, they don't sell it anymore. And so that whole, they were dependent on that company. Or, Acme just got acquired by Oracle. Oracle might decide to change something. But when it's open source, like if Bogdan gets hit by a bus tomorrow, someone else will take over. It's open source. Doesn't, you can change it. You're not dependent on one company, and if that company goes down there, you're toast. And then that brings us that in open source you have a community. There are people supported. There are lots of people in this room that know about OpenSIPS that you can help. You're not really dependent on one team, and then there are tools, continued enhancements, and also in line with the future of telecom. So a lot of people believe that not telecom, like software, is going to be more and more open source. Even bigger companies, Google, Facebook, they're all moving toward open source, and that's a big advantage of OpenSIPS. And so now, let's talk about OpenSIPS. So that was chapter 2, talk about proxy servers, what's proxy servers. And now I'd like to talk about OpenSIPS as just, a proxy servers. So again, with OpenSIPS, of course you can do call routing, NAT traversal, security, registrar server. Believe it or not, it's much better to handle all your registration in OpenSIPS, and then don't send any registrations to your Astros or FreeSwitch, PBX, or media gateways. Keep everything registered OpenSIPS, It's in the database. One goes down, you can have better redundancy, fewer messaging, and it can give you a much better flexibility, you know, to authenticate. If malicious messages come in, you can detect it, block it, and handle it right there. And again, it does, you know, SIP signaling, digit manipulation. So a lot of these here, they're similar to what I was talking about, OpenSIPS, failure detection, scripting, database. So no matter what sort of database you're using, you can hook it up to OpenSIPS, and OpenSIPS can use the same database. Like OpenSIPS has its own tables for, for instance, for registration, it uses a location table. But you can create that table in your own database and then hook OpenSIPS to that database, so you don't need to have a different database for your OpenSIPS and then a separate one for your own application. Everything can be one database. And it has management interface, so we're talking about, you know, MI or that you can talk to OpenSIPS in different ways. So if you have, you want to see what's going on, how many channels are used, or how many calls went through, or change configuration, you can use the management interface of OpenSIPS. And in release 110, they just changed that XML RPC module. So it used to be a pain to set it up because of some dependency you had before. And again, performance-wise, because OpenSIPS only handles signaling, so it can handle lots of calls, and there's no licenses. So as Bogdan mentioned, there is almost no limit on how many calls you can make per call. So I did some testing myself, and this is using dialog module, meaning because in proxy servers, there's two ways you can use a proxy server: a stateless and a stateful. Stateless means a call comes in, a message comes in, you look at two from your routing rules, and then you send it out, and you forget about it. That's the stateless routing, or stateless proxy server. A message comes in, you route it, and you forget about it. So you can have 1 million active calls in your proxy server. It doesn't do anything because everything is routed and the calls are up and the media is gone. Or you can do stateful call handling. Means you keep track of calls. So a message calls out, so you know how many calls are in ringing state, how many are in connected state, and or failure state and stuff. And then, so in a stateful proxy server, stateful configuration, I was able to do over 1,000 calls per second, and that's a lot. Really, in 10 seconds, you can set up 10,000 calls. That's beyond the carrier level. And again, OpenSIPS has distributed architecture, which means, as Bogdan was showing you in the diagrams, you can have different OpenSIPS servers in different locations. One goes down, the other one can take over, and that kind of thing. Has over 120 modules. Some of them you don't really use, but they're still there. And it has a community, it has documentations, forums, but at the same time, to use OpenSIPS, there is a learning curve, because it's everything that is really flexible. When they tell you something is flexible, that means it's going to take you a long time to learn how this thing is going to work. Because if something was not flexible, it was easy to do it. You do this and that. That's how it works. And then to really use OpenSIPS, you also need to know the concepts of SIP and signaling, and it's So there is a low learning curve to learn, but the good news is that there are mailing lists, so if you have questions, you can post a question, and it's always answered. Forums, summits, and that kind of thing. So I'm just going to go through the modules that talk a little bit about the modules of OpenSIPS. And then after that, I have some diagrams that try to show how these things come together. And that's pretty much it. So I have tried to put together a few of modules in different aspects. That these are the modules that you would most likely want to use if you use OpenSIPS. In a, you can use OpenSIPS for different applications, but in most cases you have some SIP clients, SIP phones and soft phones and stuff that you want to give service to. You have some trunks and then some call handling features. So from SIP clients' point of view, there is a registrar server module that takes care of your registration. So everybody registers, and then you have authentication modules that can authenticate the registrations. It has NAT modules, so it can, it depends if you're using TCP or UDP, you can keep the NAT open, and it can handle presence. They had BLF, now they have shared presence protocol, and it can do instant messaging, Jabber, JSON, SMS. It can do back-to-back user agent. So a back-to-back user agent is that your client talks to OpenSIPS, and then OpenSIPS talks to your other client or your media gateway, but they don't see each other. So your client only sees OpenSIPS, and it's like end-to-end, and then OpenSIPS talk to the other one. So it's like that's why it's called back-to-back user agent. It's like this side would not see anything from this side. But in a stateless proxy, when an invite comes in, OpenSIPS just send it to the other side. So your gateway knows everything about your client. And then when your gateway responds to the client, your client also sees all the information of your gateway or your PBX. But in a back-to-back user agent, you can hide from the other side. And then, of course, you need database to keep the registrations and your configurations and that kind of thing. And then for database, you have a choice of literally any kind of database you want to use. Anything you can hook to Unix, you can use with OpenSIPS. And now they have NoSQL support as well. Anybody familiar with NoSQL? So NoSQL is, all databases like MySQL, Microsoft SQL, Oracle, you write the queries, SQL stands for, tell me about that. Stateful Query Language. What's that? Oh, standard query language. So because the data is getting bigger, now there are structured. Exactly. So you have, so SQL is, your tables, your database is structured. You have these tables, keys, and indexes, and stuff. Notice when the data is getting bigger, like for instance Facebook, they have 1 billion users and billions of pictures and posts and stuff. They want to go from a structured database module to like a open database that they call NoSQL, and which is it's a different type of database, but basically they're also called big data. They can really get big. And So again, for trunks and routing modules, one of the really good modules is dynamic routing. So, which is a perfect space routing module. You can have rules, priorities, time distribution, drain mode, failure detection, rerouting. So there is one module in OpenSIPS. It's called derouting. If you go to or deroute, or is it deroute or derouting? Some dynamic derouting. So really, it gives you a lot of flexibility for your routing. So a call comes in, it says, if it starts with 01144, route it here, but if it's 01144-208, route it to this other carrier. And then if it's not available, then go to the the next rule, the best match. It looks like it gives you a huge amount of flexibility to do your routing. And then there is load balancer module. So, calls comes in, you have 10 gateways to handle these incoming calls. The load balancer module is a stateful module. It keeps track of how many channels each gateway can handle. It keeps track of how many active calls are there. It gives you reports so you can see how many active calls you have on gateway 1, 2, 3, and 4. And you can change the resources available for each gateway. And one good feature is drain mode. So you can disable one gateway, and then so let's say you want to decommission one of your PBXs or your gateways, you tell OpenSIPS, don't route anything to that gateway anymore. And then when all the active calls are completed, you can turn that off and do your maintenance work. And then when it's back on, you just enable it again. There's dial plan module, which is really a digit manipulation sort of module. So calls comes in. So some DIDs, you need to make changes. Like if it's an intercom call wants to go out, you want to add +1 in front of the number, or take +1, or if it's some malicious numbers, you want to change them to some different locations. That's also a really good module. There is a module, message operations, that gives you SIP manipulation features if you want to change user agent header to, from, that kind of things. There's NAT traversal modules, TLS, XMPP. Who's familiar with XMPP? You can tell us later what it is. Basically, it's a different protocol, so you can translate from SIP to XMPP and voice SIP. And then there are some utility modules. Talk about rate limit. You want to limit the number of calls per second to a specific trunk or gateway. You can control that here. There's a statistics module that basically gives you statistics. SNMP interface, SIP trace. So SIP trace is like basically, you guys use Wireshark and all, or other or TCP dump, ngrep. SIP trace is built-in OpenSIPS, and it records everything in the database. So if you want something goes wrong at some point of time at night, you can turn that on and you record all the SIP messages, and then you can go and see what happened, what was going on. And there's another module, SIP capture. So different guy did a different different developer, they did a different module, SIP capture, and they capture everything in, what was the name of the tool that do SIP capture? Homer, yeah, Homer. Capture everything there. And then Pike is flood detector. If someone, they sent you a flood of messages, it can detect and block all those. Perl, we were talking, it gives you a Perl module, it gives you scripting. So you can write your own feature or your own way of handling calls in Perl. And then counting. So if you have 10 gateways, each does its own call accounting. For you, you have to download all these 10 and put it together. But if you have one OpenSIPS, you can do your call accounting in one place and don't care about which gateway handled the call, because all the calls are in at one place. And it gives you some call control functionalities, you know. You can drop the call and look at the prepaid applications, you know, see if they have enough money for that call. If they don't have enough money, drop the call and that kind of thing. So, so I'm just going to go through some, I have I think 5 diagrams of that, what we talked about, and then just like, I tried to put some diagrams, so you know, a presentation you have to have some diagrams, so I put them at the end. I wasn't sure where to put them. And then, so this slide only says network diagrams. I had 29 slides. I was like, I want to make it 30, so I just put a slide that says network diagrams. This is really a PBX sort of environment. You have some SIP phones or SIP clients and some SIP trunks. That's diagram number 1. And you can also, you might also have some analog or digital gateways, so be hooked up to T1E1 cards and, or you know, analog phones or fax machines and that kind of thing. And the problem with this one is that there's single point of failure. If this guy dies, then your network is down. Everything's down. You can do anything. And so you wanna, if you want to have redundancy, you want to have 2 PBXs or 2 gateways. Wasn't sure what to call them. They call them free switch, and asterisk guys get mad if you call them asterisk free switch. Guys get upset, so I call them PBX. And then, but if you have 2 PBX, then where would your SIP phones register to? Or where your, a call comes in, which PBX will it go to? Then you need a proxy server that, uses a database, everything registers to that proxy server, and then the proxy server knows which PBX or which gateway is alive, and then it can do the handling for you. And if one goes down, it routes the call to the other one. But then really, for a better redundancy, you need to have 2 proxy servers. So if one of the proxy servers goes down, the other one will take over, and also redundant databases. So this is really a full redundant environment. So you can have a number of PBXs, 2 proxy servers, and redundant databases. And then, so there's no single point of failure. And and this is my final diagram. You can really have a number of proxy servers distributed in locations. You can have a number of gateways, and you can have groups of gateways. So let's say my group 1 is I handle all the IVRs, and then you can have a couple of servers. I handle my fax calls or conference calls, or have like a group of servers for my development or QA. And then your proxy servers know about these groups. They know how many gateways are in each group, how many channels are in each gateway, and then when a call comes in from the clients or the carriers, he knows exactly, based on rules you define in your configuration, he knows where to send the call. And then if the call doesn't go through, he knows where to send the next. And that's the whole idea of proxy server. And then, and also the other way around, if the call needs to go to PSTN, you can send it to carrier number 1, and if that one is not responding, send it to carrier number 2, or use different carriers for long distance, local calls at different locations. So again, your proxy servers knows about all the carriers you have. In each carrier, you might have multiple trunks. It knows about the trunks and would know how many channels are available in each trunk. And then again, it's connected to the database clusters, and and then with the new what they call it, internal dialogue. What was the name of the the dialogue modules can share information between the parser? Internal messaging.
The bin interface, binary internal.
Yeah, the bin interface. So these proxy servers can also basically know about each other. So if one goes down, the other one has all the active calls information, all the dialogues, and then handle the calls. And that's my 45 minutes. So now questions. Any questions? Sure.
In FreeSwitch, what's the relationship between OpenSIPS and Sophia? Are they mutually exclusive, or do they cover some of the same issues?
No, Sophia is the SIP stack for FreeSwitch. So FreeSwitch also speaks SIP, right? They understand SIP. They can receive SIP or generate SIP requests. That is done within the Sophia module of FreeSwitch. But then when a SIP message comes, they send it to OpenSIPS, and then OpenSIPS also understands SIP, and then they talk to each other SIP.
So there's some duplication in capabilities between those two?
Well, Sophia is basically an implementation of the SIP protocol for use as a UAS or UAC, basically. You could write any number of applications based off of it, and FreeSwitch is one example. OpenSIPS is more basically just a proxy and has its own implementation of handling SIP functionality.
FreeSwitch also supports other protocols besides just SIP.
Yeah.
Sophia is just their implementation of SIP using the Sophia stack. Well, there's a skinny protocol, there's there's a whole bunch of other protocols.
Jingles, XMPP, additions. But basically, every device that speaks SIP, right, they have a SIP stack, right? So FreeSwitch has a SIP stack. It's called Sophia, which lets FreeSwitch to understand SIP. Asterisk also has a SIP stack. OpenSIP also has a SIP stack. And OpenSIP is based on the lazy SIP stack architecture, which it's not lazy, it's really fast, but what it means is when a message comes in, it only parses the headers that he needs, and he ignores the rest of the message unless you need those headers, and then it goes and parses those messages, and that's why it's high performance. But OpenSIP's SIP stack, what's the OpenSIP SIP stack based on?
It's nothing. It's actually
It's own?
from scratch. Yeah, written only for OpenSIPS. So we have our own stack, and it's not so well. Let's say, obviously you cannot extract it actually as a stack. It's very well integrated into the rest of the code. So you cannot reuse it, take it out, and reuse it. Let's say for something else.
But really,
Is it something that you guys have inherited from the earlier OpenServe project, or your SIP implementation and OpenSIPS, is that something that's inherited from SER and OpenServe?
Actually, the whole OpenServe project at the moment, at the point, is simply split into two.
Yeah, so there's
Basically, it's the code, the original code from OpenServe went in both directions.
So you basically inherited.
Yeah, you can see it.
Okay, yeah, I was just curious.
but there are a few SIP stack implementations,
Like the PJ SIP.
PJ SIP is one, there's AM SIP, There is, what's that?
There's also OSIP.
OSIP, yeah. So if someone wants to make a PBX or, accelerated, so they use one of these sets.
Well, I guess my question is theoretically, you don't need Sophia. If you could get to a media handler, you don't need Sophia.
No, but FreeSwitch needs Sophia.
I understand.
Yeah.
But you don't, but an implementation like that, if you get to a media handler, you're doing the same thing. You've got the SIP stack.
Yeah, but let's say if you don't want to use FreeSwitch, you don't need Sophia. But if you want to use FreeSwitch, that's like, Sophia is not a proxy server, it's a SIP stack.
Yeah.
It's a Citron, parser.
I think perhaps your question was in terms of media handlers. If you used something, for example, like RTP proxy as a media handler, there's no need for any kind of SIP implementation at all inside RTP proxy.
Yes. That's my question.
Right, yes.
Thank you. I figured I got that, but I was, yeah.
So any other questions? Anybody uses like a network similar to this, with multiple gateways or proxy servers or, what have you guys have any advice or anything?
I would say right now, we've learned a lot. The implementation, there's been a few challenges, but we have the benefit of basically being able to control the client. So we've implemented sharding algorithms on the kind of proxy server side, so that way we can scale horizontally. If you're using handsets, obviously you can't really embed that type of logic directly onto the device, so we kind of have an advantage there. But yeah, we'll see how it goes. We haven't released it in production yet. We've done a lot of internal testing and kind of opened it up to an internal beta. We have a lot of experience kind of with a hosted PBX type platform that we're migrating away from. So yeah, we'll see once we gain a little bit more operational experience how it goes.
Are you guys using redundancy between OpenSIPS servers?
Yeah, we do. Basically, SIP signaling replication between a pair of boxes, and then we basically have multiple pairs of boxes that provide HA for our environment. And then behind that, we have a large cluster of FreeSwitch nodes that we pass back for kind of the back-to-back user agent component.
Anybody's using the promo? Oh, sorry, go ahead.
We're doing a similar thing. We don't actually register SIP clients directly yet. We're putting together a completely separate OpenSIPS cluster for SIP clients of audio codes, gateways. That the PBXs we have are Cisco's or Access, FreeSwitch, generic stuff. But none of those have handled the audio codes correctly, and we found that OpenSIPS, because it doesn't get involved in the media, does a great job. So we're doing that. Seriously, it's a lot easier. But we've only treated things around the edges, big blocks. We haven't actually talked to individual devices until just now. We're going to start with a separate registrar, so we'll treat ourselves like our own little PBX cloud. And the central SIP core is still just a pair of proxies in HA, and the database is also replicated. So nothing really fancy. And we mentioned at the top the NAT firewall, so that's all identified as well. Just 2 sites, 2 locations, 2 separate licenses, 2 separate PRI gateways.
Can you use NAT?
No, there's no
firewall.
any.
You have a public IP address?
It's all public IP addresses,
OpenSIPS.
other than when you flip to the inside, when you go between the session border controller outside and inside.
So you have 2 NIC cards on the OpenSIPS servers, one for inside,
No, the
one
OpenSIPS is all on the private IP side. But we don't deal with NAT per se.
Okay.
We use the session border controllers
For
to
your NAT.
rewrite the stuff. So there's no connection. You can't actually get the real media from the outside to the inside by running through a NAT router. It has to go through the SBC.
Right.
Tear it apart, regenerate the packet, go to the other side, because Cisco handsets are vulnerable to being attacked by specially crafted G711 packets. So we didn't want that.
That's good. So any other question? Thank you, everyone.